All right. So welcome everyone. Sorry about that little glitch. We thought we were live, but we weren't live, but now I think we're actually live. So yeah, welcome. My name is Roland. I'm one of the mentors at Game of Apps. Um, so actually, just to confirm that, to make sure that we're live, if you are hearing me and seeing this, can you please say yes or something on the chat so that we know that we are live? So I'm just going to wait for someone to say that you can see and hear us, just to confirm before we move on. Okay, Adrian. So Adrian says yes. Okay, awesome. So we are live. Okay, great. So yeah, thanks again for joining us. And for those of you who are joining us from last week, thank you for joining us again. And if you're new this week, welcome. I want to introduce you to our guest tonight, Wilbur. He's also one of the mentors at Game of Apps. So let me switch over to Wilbur. All right. Hello, Wilbur.
Hi, everyone. Hi. Yeah, I'm Wilbur. I joined Game of Apps just last year. For people who have done it before, I was a mentor for you all last year. That was really fun. And for those that don't know me, I graduated from UBC in Vancouver, and right now I'm working for Google in San Francisco. And I'm excited to chat with Roland about random things on this channel.
Okay, awesome. Thanks, Wilbur. Welcome. All right, so let's. I just want to say welcome to the people in the audience. So if you're with us on the live stream, please just enter something in the chat. Tell us what city you're from, and whether you're in high school or elementary school, or if you're post high school, you can say you're post high school as well. So we can welcome you. So Adrian has already said yes. So hello, Adrian. Welcome again. You were with us last week, right? And then William is also online. So William, welcome. Nice to see you again. So if you're with us in the audience, feel free to say hi at any time, and then we can greet you. So yeah. So just a quick recap if you're new with us tonight. This is the second session. So last week we built a simple app where we have a plane, and then you can draw the path for the plane. So what we want to build by the end of this, I guess we're looking at maybe 8 weeks. So we have this week plus another 6 weeks to go. We want to build a simple air traffic controller game where basically you control a plane, and then you tell the plane where to go. So the plane shows up, and then the plane has a certain destination that it wants to get to. And then you draw the path from the plane to its destination. And then the plane starts going on that path. And then other planes might show up, and then you have to draw their destinations too. So your goal is to guide them safely to their destination without having any of the planes have a mid-air collision. And then maybe we could get fancy. Some of the planes might want to land at the airport. So there'll be an airport that they can land at. So then you'll guide them to the airport to land to. So that's kind of the high level concept of what we wanted to build. As we mentioned last week, we want this to be interactive. And so we're not just building kind of what our idea of the game is. So we want to provide you guys a chance to provide input into the game also. So if you wanted to see certain things, or you think that, oh, this would be cool to have, then let us know, and we'll see if we can incorporate that into the game. Yeah. So yeah, Wilbur, what type of games do you play? Like this type of air traffic controller game? Have you played? I'm sure there's something similar like this out there, right?
Oh, yeah.
Yeah.
When you mentioned that, my first thought is for those who also have done Game of Apps before, you will know Justin for sure. He's one of the big design mentors. I'm on the dev side, the development side. Justin's on the design side. When you mentioned about flight stuff, he's a advent flight simulator gamer.
Okay.
Like he told me recently, he just bought a like GTX 3080 Ti, which is these are really, really expensive graphics cards, top of the line. And he would because he's really into flight simulators. And then yeah, you need crazy graphics to run that.
Okay.
But sorry, anyway, sorry. That was a totally off tangent. To
Yeah,
answer
no,
your
no
question
worries.
about what do I like to play? I like to play games like Overwatch. There's no planes there. StarCraft sometimes. There's some planes there, sci-fi planes. Yeah, that kind of stuff. Blizzard games, I suppose.
Okay. Yeah. So those in the audience, if you have a favorite game, why don't you let us know what your favorite game is, or maybe what are some of the games that you play? Feel free to enter that into the chat. So yeah, while you're doing that, the plan for today, we'll go over just a quick overview of what we're hoping to build today. So as we do that later, you'll get a chance to kind of provide input as well into what you think we might be able to add. And if it makes sense and if it's something that we could do today, then we'll definitely do that. Okay. All right. So yeah, feel free to keep interacting with us on the chat. I'm going to start sketching out what we have so far and then where we want to go. So Wilbur, you can feel free to provide input as well if you think that we should do something different.
Sure.
So what we built last week was that we have a plane that shows up on the screen. So we just have one plane. It's kind of, and then you can tap on the plane. When you tap on the plane, it switches into, I guess I'm calling it the path tracing mode. So we have the normal game mode, and then when you click on the plane, it goes into the path tracing mode where you can now trace the path for the plane for it to go. So if I'm just going to draw that here. So initially, so pardon my drawing again. I'm not the best drawer, but we have a plane that's on the
It's
screen.
not bad actually.
Yeah.
Very artistic.
So
it's a penguin plane.
Yeah. So if the plane is there and you start drawing a path on the screen, nothing will happen. You got to select the plane first. So if let's say I've tapped on the plane, I've selected it, then now I can draw a path for that plane. Okay. So if I drew that path, then that's where I want the plane to go, right? So that's kind of where we ended it up last week. Last week we were able to select the plane and then draw a path. Okay. So let's go a bit deeper into what we actually did. So oops. All right. So what we did was actually, if I'm going to draw like a 3D view. So if this is the game board for the app, we had actually like three planes. Okay. So the plane view, so the plane lives in this layer. Okay, so the plane there, and presumably in the future when we have more planes, they will all live on that layer. And then this top layer is the trace. We call that trace path view. And then this would be the planes. It's hard to write, planes view. And this would be the paths view. Okay, so initially the trace path view is transparent, so you can see right through it. And what happens is that the trace path view initially, when it starts off as disabled. So that's why even if you try to trace a path on the trace path view, nothing will happen. Okay, now it also passes all the touches. So if I were to touch my finger down here, it'll pass that touch event down to the next layer below. Okay, so then I can select the plane. If I touch the plane, then what happens is I go into this trace path mode. So in the trace path mode, the trace path view now becomes enabled. And then now at this point, I can draw a path on this layer. Okay, so that's the path that I want to associate with this plane. Okay, so when I finish tracing the path and my finger goes up and off the screen, then what happens is our program then takes that path, calculates what the Bezier path is for this curve, and then associates that with the plane, and then it redraws that path down here. I don't know if I can draw the same thing. Okay, so now we have a paths view that shows that path, and then the trace path view becomes disabled again, and then it gets cleared up. So if you were running the app from last week, the trace path view, when you draw the path, it's black. So, and then after you let go of your finger and it gets redrawn on the paths view, it's redrawn as gray. Okay, so then you know that this paths view, the gray paths view is where the plane is supposed to fly. Okay, so any questions from the audience so far? Wilbur, have you done anything like this in any of your projects where you have like multiple layers of a UI?
Yeah, so multiple layers of UI is pretty common in game design for sure. The most common one you'll probably see for this kind of stuff is probably with background and things you can interact with.
Yeah.
As you program more, you'll learn that like drawing 3D objects in a game is pretty tough for your computer or your phone to do. And so the hack around this, what a lot of companies do, is for far away scenes, like maybe cities in the far background, or just general big stuff that's very far away that you don't interact with. They're actually just random to like imagine a sheet of paper they put on the background and they put an image there. Now, to trick you into thinking that the background is 3D, they may have like one sheet of paper for just the buildings that's closer, and then one sheet of paper for the skies that's much farther. And so that you feel like the buildings have a little bit of depth to them, but they're usually just single sheets of paper.
Yeah. Okay, awesome, great. Okay, so if there are no questions on what we've built so far, I'm going to start talking about what I'm thinking we can build for today. So as I go through that, people in the audience, please feel free to chime in and let us know if there's something slightly different or something that you want us to add. Okay, so far we've, as I said, we have a plane, and we can draw its path. Okay, and then that's it, right? So what I want to do this week is I want to be able to animate this plane on this path. So the plane starts there, and then a little bit later on we want the plane to be here. Then a little bit later on, we want the plane to be there. Okay, so in order to do that, we have to do two things, right? First is we have to be able to make the plane follow the path. But secondly, you can see that the orientation of the plane changes, right? Like we don't want the plane to always be pointing up, because that's going to look funny, right? So not only do we want to move the plane, but we also want to rotate the plane so that it's following the path. Okay, so that's one thing that we want to build today. And then also we want to introduce the concept of a run loop. Does anyone in the audience know what a run loop is? So if you kind of have an idea of what a run loop is, or if you want to guess, just type it in the chat. If you play games, you've probably encountered run loops, right?
Is it where I run on a loop, like a lap, running in circles?
That's a. I guess if you look at the words, that kind of that would kind of make sense.
Yeah, so I guess a run loop. I guess if you don't program, it's very unintuitive. It makes sense because the function is called run.
Yeah. Okay. If no one's guessing, then yeah, okay.
Yeah, it's not very intuitive.
Yeah, it's not very intuitive. So, okay, think of it this way, right? So you see here, I've drawn. Oh, okay. Let's see. Adrian says, not sure. Okay. Do you want to?
Oh no, now he's gonna be conscious of. Oh no, I just put not sure, and no, I.
Do you want to guess? Okay, it has something to do. It has something to do with you see these 4 planes that I drew. The first one is at this point. The second one is at that point. The third one is at this point, and the fourth one is at, well, okay. The fourth one is oriented wrong, but it supposedly should be in that point. Okay, we'll give you another maybe 10 seconds to guess, and if no one guesses, then we'll cover it. If you think of turn-based games, right? Like think of just a simple game like chess, right? I move. Let's say I'm playing chess against Wilbur. I move, and then Wilbur moves, and then I move, then Wilbur moves, right? So it's illegal for me to move, and then for me to move again before Wilbur moves, right? So
I hope
is
so.
that
Unless I, say, look over there.
that's true, yeah. Okay, so let's go over what the run loop is then. So you can correct me if I'm wrong, Wilbur, but a run loop is basically similar to this turn-based thing that we talked about, where we have a loop, and in the loop we go through every single thing that needs to be updated. So, for example, in that game of chess, in our run loop, we would have two things, right? Execute Roland's move, and then execute Wilbur's move, and then that's the end of one loop. Then we go into the next loop, execute Roland's move, and then execute Wilbur's move, and then that's the end of the second loop. And then we keep repeating that loop until the game ends, basically. So that's a simple definition. Anything you want to add to that?
Or maybe like, I'm trying to think about a run loop example. Maybe another one that you can think about is Tetris. I think Tetris is the game that everyone knows about. A basic run loop for Tetris might be, keep checking until a block has hit the ceiling. And the reason why it's called loop is because it's always checking for something. It's running something. And the run for Tetris is, I'm gonna keep putting blocks into the game. And every time it loops, it will move every block a little bit. And then at the end of moving it, it'll check, hey, have we hit the ceiling? And it'll constantly be checking if we hit the ceiling or not. If it did, then, you died. The loop is just constantly be checking stuff.
Yeah. Okay, awesome. Yeah, great. Thanks, Wilbur. So in our example here, let me just redraw this again. So we start off with a plane here, and the plane has a path, right? So in the first run loop, it's going to say, okay, the plane is going to move a little bit. So the plane is going to move this way, but then it's also going to change. It's going to rotate a little bit so that it's following the path. So that's the first run loop. And then the next run loop, the plane will now be in this position, and it would have rotated a little bit more. Okay, now if let's say we had 2 planes in my game board, then in each run loop, it has to do the updates for all of the planes on the board, right? So let's say the next run loop is going to redraw this plane this way. And then it's going to, let's say this has a path this way. Then it's going to redraw that plane this way. Okay, so each time around the run loop, it updates every single piece on the board. So however many planes we have, it needs to update it. It needs to update its position, and then it needs to update its orientation.
Oh, now that I think about it, maybe a way to explain it, should we teach them about frames? Like, how monitors have FPS? I don't know if they know that.
They might FPS, I think, probably there. Yeah. So why don't you go ahead and explain that?
Sure, I'll try that angle. Just because I feel like it might feel like they don't know when the loop, when is it one cycle? A loop is multiple cycles, but then they may not know how long is a cycle. Is it like, oh, 1 second? Is it something? But you guys might know about how maybe there's a YouTube videos. YouTube videos have different kinds of frames per second. You might have realized there's 30 frames per second, there's 60 frames per second. It just means how smooth the video is. And for games, it's each loop has multiple sessions, and each sessions is connected to the frame rate that you're running it at. Let's go 30. So when I say 30, it means every second. So every second there are 30 times the loop would check stuff 30 times within a second. And when I mean check, just use the plane for the example. Let's say we have a plane with a specific velocity. And you might know in physics, velocity is just meters per second. You have a distance, you have a time. Now the distance is simple. Okay, then I want the plane to be here within this time. But then what is this time? This is where the loop and the frames per second comes into play. Because within a second, let's say we're doing 30 frames, it means that every loop is 1/30th of a frame. Sorry, 1/30th of a second. So that means when you have to calculate the plane's next position, you're doing the time between the next loop and the current loop is 1/30th of a second for the time. And then the meter is just meters. I hope that makes sense. Okay. If not, please put in comments. Yeah. Maybe I butchered that explanation a lot.
It sounded good to me, but yeah, if it didn't make sense, ask a question in the comment. So while you're doing, I'll move on a little bit while you do that. So yeah, we'll introduce the run loop. So the run loop is basically when we're updating. Oh, okay. So Adrian says it does make sense. Okay, awesome. So we have the run loop. Now we also want to introduce what you saw here, the ability to have more than one plane in the game field, right? So just for we're going to be building this game in stages, right? So what I'm going to do is I'm going to add a button in the app, and each time I tap on that button, it's going to spawn a new plane. Okay, so when I press that button, it's going to spawn a new plane. It's just going to randomly place it somewhere in the game field, in the playing field, and then I can then tap on that plane and give it a path. Once I give it a path, then it'll start animating. Okay, so that's what I'm hoping to have built by the end of this evening. So we'll have the ability for a plane to animate along its path, and then we'll have the ability to add additional planes by pressing this spawn button. And then new planes will come into the playing field, and then we can also draw a path for that plane, and then it'll animate it as part of the run loop. Okay, so if any thoughts or comments on what we want to build, please enter it in the chat. Okay, otherwise then we'll go into the second part of this evening now, where we're going to demo some of the code that I've pre-written. So yeah, so Wilbur, you're feel free to hang out, but if you need to take off, you can leave too. Thanks so much for joining us and for sharing some of your thoughts on the game. So yeah,
thanks for having me.
Yeah, so Wilbur is one of our mentors in Game of Apps. So if you decide to join Game of Apps for our next season, starting in September, then you'll get to see a bit more of Wilbur.
Yeah, I can't wait to see y'all. That'll be fun.
All right. Okay, thanks, Wilbur. I'll talk to you in a bit.
Toodles.
All right, thanks. Okay, so let me share my screen. Just give me 1 second. I'll get set up here. And then you can look at my Xcode. All right. So I think you should be able to see my Xcode now. Let me add myself as a picture in picture. Hope this works. Oh, that's
Oh,
that's Wilbur. Let me fix that so it'll be me and not Wilbur.
I'm glad I wasn't doing anything shady.
That's true. Just give
I
me
was
one
like,
second.
oh, hello, I see a dashboard.
Let me
Behind the
just,
scenes shot.
I know this is behind the scenes. So let me figure this out.
Time to look at all your folders on the desktop there.
Oh, that's true. Okay, so now it's showing me. Okay. All right. So this is what we had from last week, demo one, right? So I'm just going to run it just to remind you guys how it looks. And while it's running, let me show you some interesting things here in Xcode. So you see, this is my app, and I can choose to run it on a different types of emulators, right? All the different iOS devices. But Apple has now made it so that we are now able to run iOS apps on a Mac as well. So I can actually run this app on my Mac, which is what I'm doing here. Okay, so this is an iOS app, but it's running on a Mac, and so that's why it's running as a window on my Mac. Okay, so from last week, this is what we built. I can select this plane, and then I'm now in the tracing mode, and I can then trace a path for that plane. When I let go, it redraws that path as gray in the paths view, and then that's it. I can select the plane again and draw a different path, and then it'll overwrite the old path. But you can see there's a few deficiencies here, right? One, when I click on this button on this plane, I don't know whether I'm in the tracing path mode or not, because it looks exactly the same, right? So I can trace a path here, but if I didn't press on this plane, I might think that I can draw something, but if I draw something, nothing's happening, because there's no indication that I'm now in the tracing path mode, right? Other than me remembering that I've actually tapped on that plane. So that's one deficiency that we should note. Okay, so that's what we got up to last week. So now let's jump and add some stuff for this week. So rather than typing it in, what I'm going to do is I'm just going to jump to different commits in the code base here, so that so it'll save some time, and then I'll explain the code here. So this is where we were last week. I'm going to jump to this commit, rotate plane button based on point in path. Okay, so I'm going to go to that commit, 49cc565. So I provided the code to you guys, GitHub last week. So if you want to download the code, you can. If you have a Mac, then you can install Xcode, and you can run this code as well. So that's one way you can try this out. The other way that I offer to you, and some of you have already taken advantage of this, is if you send me your Apple ID, I can add you as a beta tester to this, and then using TestFlight, which you have to install from the Apple App Store, I can push out the weekly builds, and then you can install that onto your iOS device. Okay, so I jump to this commit, and let's see what are the changes here. So you see my commit message, this rotate plane button based on point in path. So let's take a look at our code. Actually, let me demo it first, and then we'll take a look at the code. Oh, I added this too. This doesn't do anything right now, but presumably in the future we'll have easy, medium, and difficult modes. But right now they all do the same thing. Okay, so I select the plane, and let me draw a path. So you notice when I let go and it ended the trace path mode, the plane rotated and pointed to where the path is going. Okay, so let me try that again. So I clicked on the plane. I'm going to go downwards now. Now the plane is pointing downwards. So basically it's going to point itself to wherever the path is going. Okay, so that's the code that we've added. Okay, so it's a little bit better than last week's now, right? So the plane is pointing. So let's see what we added. Okay, so remember this method from last week, trace path completed. This is called whenever the user has finished tracing. So when the user lifts their finger off of the screen, this method is called. And then last week we did a couple things, right? We stopped tracing paths, so we exited the trace path mode. We drew the path of the plane. This is the gray path that we drew. And then this is the new thing that we added, orient to path. Okay, so we have a method called orient to path. We pass in the path that the user drew, the Bezier path, and also the plane button that this belongs to. So let's take a look at orient to path. What does it do? Okay, so the first thing it does is it creates this object called a plane. Okay, so we'll take a look at that in 1 second. And then it assigns this Bezier path to that plane's path. And then it creates a rotation. That rotation is a heading in radians. If you've taken geometry, I don't know what year in high school you take radians in geometry. I don't remember now. But I think it's covered in high school, right? So, William, I know that you've just graduated high school. Did you cover radians in your math or geometry classes in school? Just let us know, because I don't remember when I covered radians in school. As you might be able to guess, it's been a long, long time since I was in high school. So we calculate the rotation. So the plane, we tell the plane what its path is. Okay. So William says, yeah, in grade 10. Okay. So you covered radians in geometry in grade 10. Thank you, William. So what I've done is I've given the plane its path, and then given that path, the plane can now calculate its heading for me. And the heading is in radians. So I get that back here, and then I take the plane button and I transform it. And the transformation is a rotation angle, and the rotation angle is whatever the plane told me its heading is in radians. Okay, so that's what orient to path does. Okay, so if there's any questions or if something that's not clear, just feel free to ask a question in the chat. You'll be able to get this source code as well too. The other thing I want to show you is this plane. So what is a plane? So a plane is what we're calling a data model. Okay, so in most of our apps that we build, we have what's called a data model layer. So the data model is our objects in our program that represents the entities that we're dealing with. So in this case, we have plane is a pretty important entity because we're going to have a number of planes, right? So let's take a look at this plane class. So we have a plane class here. So this is the data model, and it has a few properties. So we see path is one of these properties, right? So all planes have a path because it needs to follow a specific path. Planes also have a velocity. Okay, so right now I just defined velocity as 5 different speeds, speed 1 up to speed 5. The units don't really matter, but it just means that there's 5 different speeds. And by default, when you create a plane, its speed will be speed 1. Okay, so just by default. We also have a number of other properties. We have a read-only property called percentage complete. Percentage complete will be a number from 0 to 1, 1 being 100%, 0 would be 0%. And this number represents what percentage of the plane's path it has completed. So if the percentage complete is 0.5, that means the plane has completed half of its path, so it's in the middle of its path. Okay. We have another property here. This is called a calculated property. So in modern languages such as Swift or Kotlin, we can have properties that are not specific values, but these are calculated at runtime. So the center position is a property, but whenever I say, plane, tell me what your center position is, it will execute this code and calculate dynamically at runtime what is my center position. Okay, so the important thing here is that it takes the path and it takes it returns the point at fraction of length. So given my percentage completion, so let's say I'm at 0.5, so 50% of my path, this method here will return to me what is the point that's exactly at 50% of my path. and that'll be my center position. Okay. I have a number of other methods here. Move. I won't go through this all because we won't have time to go through all the code. But this function move basically moves the plane. So it moves from its current position to its new position. And it does that by taking the speed and calculating what is my new fraction. And then it increments my percentage completion. And then we finally get to this one, which is what we saw earlier, heading in radians. So the important thing here is this geometrical formula, right? We get some sort of tangent given the fraction of the path that I've completed, and then we return here in radians. Okay, so I won't go through the calculations now, but this returns to me the right heading. Okay, so what you've noticed here, let's go back to the previous. What you've noticed here is that we have a plane object. The plane object knows how to calculate its center position. It knows how to calculate its heading. So all I need to do is I need to tell the plane to move. It'll move and it'll update its percentage completion. And then whenever I query its center position, it'll be able to return to me its center position. And whenever I ask for its heading in radians, it also knows how to return that. Okay, so that's what a plane does. All right. So we went through very quickly, but what we've gone over here is a lot of the concepts of object-oriented programming, where a plane is an object and the object knows certain things that it can do on its own. So a plane on its own here knows how to calculate its heading, and it also knows how to move. Okay. All right. So this is orient to path. Any questions from the audience? Okay. If not, then I'm going to keep going. All right. So now we know how to orient the plane. Now the next thing we want to do is we want to be able to do a run loop. Okay. So let's move on to this commit here. So git checkout 51B9DE4. All right. So what have we added here? We've added the ability for the plane to move and to orient itself according to its path. So let's demo that and see how it works. Okay. So I select the plane. I draw its path. Okay. When I let go, you notice that the plane is moving. And it's moving along the path, and it's also rotating so that it's pointing to its path. Okay. So that's pretty great. I noticed one thing though. Do you notice that the movements are pretty discrete, right? It kind of jumps from one spot to the next spot, and then it jumps from one spot to the next spot. Okay, so that's a deficiency in this iteration right now. But other than that, it's moving along its path, which is good. Okay, let me try to select this plane. Okay, so I've selected it. So you notice that it stopped moving because the moment I tapped on the plane, we've now entered back into the trace path mode. So now I can draw a new path for this plane. And then if I let go, then the plane starts moving on its new path because I've given it a new path. Okay, then the old path is gone. All right, so that's what this does. Okay, so let's go over the code to see what we've included. Okay, so let's look here. The first thing I want to show you is we have now something called a game loop. We have a game loop, a property called isGameLoopRunning, and we have a timer called a game loop timer. Okay, so this isGameLoopRunning is a Boolean, and this construct here is again this did set is called whenever I change the value of isGameLoopRunning. So whenever I set the value, whether it's true or false, it will execute this. And if I set it to true, that means we want to start the game loop. And if I set it to false, then we want to stop the game loop. So this is how when we're toggling back and forth between trace path mode, and normal game mode. So normal game mode would be when the game loop is running, and trace path mode will be when the game loop has stopped. Okay. So let's see what happens when I start the game loop. When I start the game loop, okay, here we go. Okay. So you notice when I call start game loop, the first thing it does is call stop game loop. All that does is it calls this to make sure it does the proper cleanup. Okay. I guess I could have entered this code in here too. Instead of calling stop game loop, I could have done this, and then I don't need that, right? But the reason I did this is because right now stop game loop might just be one line, but maybe in the future there might be other things that I want to do when I stop the game loop. So rather than duplicating all of this code in here, I can just call stop game loop. Then it'll properly stop it and clear out anything that it needs to be cleared. Okay, so it calls stop game loop, and then here it sets the timer. So what it does is it creates a timer, and the time interval is 1.0. So this is 1 second. So going back to what Wilbur was talking, the frames per second here is 1 FPS. So it's a pretty low res game, and that's why you saw when we started it, the plane was jumping pretty discreetly, right? So the time interval, so every second we execute the game loop, and when this timer fires, it calls the game loop timer fired, and so this one here is executed once every second. Okay, so what does it do? It calls view model.plane.move. So this is something new. We haven't seen this before, so I've just introduced that. So hold on to that. I'll explain what that is in a bit. So we have a plane, and we're telling the plane to move. Okay, and then we're drawing the plane's path, and we're orienting the plane, and then we're moving the plane on the path. Okay. So these are the three things that we do when the game loop timer has fired. Okay, so let's dissect this a bit more. In view, what is view model? So I have a new class here called a game board view model. So I won't go into this architecture too much, but for iOS and Apple development, the most common architecture is what's called MVVM, model view model. So the model is the data model. We just showed you earlier the plane, right? This is the data model. These are the objects that represent all the entities in your app. The view is basically the view controller, this here. So this screen here is the view. All the visible items are in our view. And we have this view controller corresponds to that screen. So that's the view. The plane is the model, and then the view model is kind of what connects the data model and the view. So I have something called a game board view model, and you can see that it basically just has three things. It has the plane, it has the path shape. Basically, this is the path that this plane is supposed to take, and this is the plane view. This is the actual view component. In our case, it's a UI button. This is the view component that corresponds to this plane. So why did I declare that here? Because I know that I will have multiple planes in my game board. So in our previous code, we just basically put a plane object and a shape object right in our view controller. So we had that defined up here. But now I've replaced that with a view model because I know that I'm going to have more than one plane. So rather than having 5 UI buttons, having 5 plane objects and 5 path objects, what I can do is I can just have 5 view model objects, and each one of these view model objects would then encapsulate the plane, its path, and the button. Okay, so that's what the view model does. Okay, and then we've seen these already. I won't show you the code, but if you want to look at the code later, I've updated draw plane path. Let me just jump to it right now. I've updated it so that not only does it draw the plane path, but it also starts truncating it. You notice, let me show you what I mean. If I draw this path, you see the path started here, right? But as the plane moves, you'll notice that the first part of the path starts getting erased. So the path actually started here where my arrow is, but the path from here to where the plane is now erased, right? And that's what we expect, right? We don't want to see the path, the complete path. We just want to see the path from where the plane is to where its destination is. So this this has been updated here so that the stroke start is now updated so that we don't draw the path from where it started. We draw it from where the plane is currently now. Okay, that way we erase the first part of the path. Okay, orient to path we've already talked about. And then move plane on path, that's a new method that we've added. And basically what that does, you can see it's just one line, right? Because the plane knows how to calculate its center position, then I just update the plane image. It's a UI button, right? I update its center point to what the data model, so this plane is the data model. I ask the data model, tell me your center position, and then I go to the view is the UI button, and I tell the button, update your center to be the center position that I've retrieved from the data model. Okay, so this is a simple one-liner, and the reason I can do that is because in my plane data model, it does all the hard work here. It knows how to calculate its center position. Okay. All right. Any questions? Okay, it's 7:50, so I'm gonna run through the next little bit, and then I want to leave the last 5 minutes maybe for some more interaction and Q&A. Okay, so let me jump. So you notice that the animations were not smooth, right? So this next commit, I made the animation smooth. So let me just jump to that so that you can see what I did to make the animation smooth. There's a couple of ways to do this. One is I can increase the frame rate, right? So what was my frame rate? Initially, my frame rate was 1, right? So I turned that into a property here, game loop interval. So I can increase this to some higher number, but there's a limitation on what I can do because I'm operating at a very high level, at quite a high level. Here, I'm not operating at the low graphics card level, right? At GPU level. So because of that, there's a limit as to how fast I want my interval to be. But I can fake it. So even though I'm at 1 frame per second, what I've done to fake it is that when I'm updating the move, what I've done is I've encapsulated inside an animation. So rather than discretely moving the plane from one spot to the other, I'm telling the system, animate from the current position to the position that it's going to be at. And then the same with the rotation also. The rotation will be animated. So iOS knows how to animate things. So I'm telling it, between now and the next run loop, animate the plane from this spot to the next. So if we run this, okay. So you'll see now it looks very smooth. You don't see any discrete jumps at all because the plane's position is only actually being updated once every second. But between those seconds, iOS is animating the plane moving from its current spot to the next spot. And by the time it gets to the next spot, the run loop executes again, and then it has a new position, and then it animates to that new position. So this is basically a sequence of animating from one spot to the next, and animating from that spot to the next, animating from that spot to the next. But from a user's perspective, it looks pretty smooth. Right? Okay, so that's how I did the animation. Okay, let's jump to. Let me jump to this one, I guess. Actually, let's go to the last one. Okay, so the last thing I want to show you is we added the ability to spawn new planes. All right, so now when we start off, we have no planes on the screen. So when I click on spawn, then we have a plane here. Oh, it started down here. But now I can select that plane and notice one thing. Now the plane turned black. So now it tells me that I'm in a different mode and I can draw the path for that plane. And that plane now starts animating. I can spawn a new plane. And then now if I select that plane turns black. So now I know that I'm operating on this plane and I can draw a new path for that plane. Now they're both animating. I can go back to the first plane. And instead of going this way, I said, no, I don't want you to collide. So let's go this way. Okay. I can spawn a new plane and I can go this, select that, and it can go this way. Okay, so you see all these planes are now animating on their own. Oh, it looks like we might have a collision. Okay, so they collided, but we have no code that detects collision yet, right? But in our real game, we don't want that to happen, right? Also, in our real game, you notice how they get to the end of the path and then they just stop there? That's not physically possible, right? So, so that's something that we have to deal with at some point in our game too. Okay, so let me just walk you through quickly what I've done here. So taking advantage of the view model, now you'll notice that my view model is now an array. So I have an array of view models. And so now I can insert one or more plane view models into this array. Each time I spawn a new plane, I'll create a new plane view model and I'll insert that here. And then in my run loops, when I draw the plane path, I'm going to iterate through every single plane view in my array, every single plane view model in my array, and then I'll update that. And the same with the orientation and the same with the move. So basically I'm iterating over the array. For each plane view model in my array, I update its position, I update its orientation, I update its plane path. And yeah, so that's basically it. I see Wilbur. Wilbur is still here. Wilbur, can I bring you back?
Sure.
Okay, great. So let me bring Wilbur back. Okay. So yeah, it was a quick demo. Any thoughts or questions from the audience? Any comments from you, Wilbur?
I liked it when the planes collided.
Oh, yeah, too bad there was no explosion though. Nothing
I
happened.
know. I remember when I first started doing this, I'm always like, oh, hey, I want to see what happens. And then it's like, oh, nothing happens. And well, now I know that when you in programming, when you have to even code the behaviors when things don't go right.
Yes. Yeah. So we'll definitely add that in a future iteration of this. If one of you students on the audience want to design some animating explosion, we can incorporate that when they collide. If you're so up to it. So any questions? Please feel free to post. Otherwise, these are the resources. We gave this out last week too, but it's over here. If you want to download the code, here's the GitHub link. You can download the code. The one that I just demoed right now, I think it should be up there already. If not, then I'll push it as soon as we finish this live stream. And then if you want to join the beta testing, give me your Apple ID email, and I'll add you to it. So what'll happen is once I add you to the team, you'll get an invitation to join the beta testing team. And then once you accept that, then I will send you the build. And then you'll get a second email. Actually, if you've downloaded TestFlight, you should get a notification on TestFlight saying that air traffic is now available. Then you can download that. All right. Any other thoughts or questions? What did you guys think, audience? Was that a good pace, or was that too slow, too fast? Anything you want to see different?
All right. I guess it's good.
Okay. Yeah, I guess if we're all good.
Awesome.
William says pace was fine. Okay, awesome, great. Yeah. I also want to encourage you, like, if let's say there's something that you missed during the live stream, and you download the code, and then you take a look at it, and something is not clear, please feel free to come back to this video and post something on the comments. So the chat will be closed by the time when we finish this live stream. But you can post a comment, and then we will look at the comment, and we can continue the discussion through the comments. Adrian says it was good. Thanks. Thanks, Adrian. You're welcome.
Yeah, thank you for you two for sticking through this.
Yeah.
I hope that we weren't dry or anything. It's a long hour, I'm sure.
Yeah. Okay. Oops. Sorry.
Oh, hello again.
Press the wrong button. All right. Okay. So I guess then that's it for today. Thanks all for joining us. Hope to see you again next week. And as I said, if you want to continue the discussions throughout the week, post a comment on this video after it's posted, and then we can continue that way. Wilbur, thank you so much for joining us from San
Thank you for
Francisco.
having me.
Yeah. So take care, everyone. Have a good week. Bye-bye.